Almost there, almost through all the videos. Now we're going to talk about the geometry of multiple bonds, okay? So for purposes of talking about molecular geometry, experimental evidence indicates that 2 or 3 electron pairs in a double and triple bond behave like a single bond in terms of the geometry. So if we look here, here's an example of 2 molecules. The one on the left obviously has no double bonds. The one on the right has double bonds. Both molecules, in terms of their geometry, are trigonoplanar with 120-degree bond angles here, okay? So the number of regions of electron density that surrounds a central atom determines the electron pair geometry around that atom, okay? And the region of electron density can be a single, double, or triple bond, or a lone pair, okay? So the idea here is that the geometries don't really change when you have a double bond in place of a single bond, okay? It's pretty much all going to be the same. So let's do some examples here. Describe the molecular geometries in the following molecules. So why don't you pause the video, actually write down the Lewis structures for all of these molecules, and then we'll use those Lewis structures to answer these problems together. Okay, so let's just start with the first one. So carbon dioxide, so its structure looks something like this. Hopefully this is what you wrote down. It's an ugly carbon atom, so I'll fix it. Okay, so let's see here. What is its molecular geometry? Well, remember, act like the double bonds are single bonds. So this is going to be 1, 2 domains here, okay? 2 domains, no non-bonding domains. So this is going to be linear from our last video. Okay. So let's keep moving right along. So this guy is going to look something like this. Okay. So you can really pick a carbon atom, and it doesn't really matter. Okay, so remember the double bonds are going to act like it's a single bond in terms of geometry. So there's 1, 2, 3 domains here, no non-bonding. This is going to be trigonoplanar. Okay, let's move right along here. So this guy, this one had a triple bond in it when you drew the Lewis structure. I hope you got this. Okay. So again, looking at the carbon atom here, there's 1, 2 domains, no non-bonding pairs. This is linear. Okay. It's pretty easy. Again, just reiterating, you treat, for this purpose, for finding the geometry, you treat the double and triple bonds just like they're a single bond. Okay, so this one, this guy looks like this. This is its Lewis structure. Okay, and if you're having any trouble with Lewis structures, reach out to me. I'm happy to help. Happy to, if you didn't get these structures, go back, see why you didn't get it. If you have any questions, just email me. Maybe I made a mistake, which is definitely a possibility at this hour as I'm filming. Okay, so we're just going to concern ourselves with the carbon here. Okay, so there are, let's see here. This one actually doesn't have a multiple bond, so I don't really know why it's in in this practice here, unless I'm going crazy, but I don't think it does. Yeah, okay, so this is just 1, 2, 3, 4 around the carbon. This is going to be tetragonal. Tetrahedral, excuse me. Not tetragonal, I'm sorry, tetrahedral. Okay, so that's just an example where you have kind of a bigger molecule. So we're just looking at the carbon here. But I'm pretty sure that doesn't need any double bonds. Let me know if it does. Okay, let me know if I made a mistake. But that's pretty much it for this video. It's shorter than the last one. And then our final video for the semester, we're going to be talking about polarity of molecules. So I'll see you in that video.